Good day, everyone, and welcome to our ninth discussion in this course. I am Jonathan Salmayo, and I'm going to share to you about the design criterion of dams. To begin, let us know the abstract. This content provides an overview concerning the design criteria of dams, including structure of dams, classification of dams, general planning, and design parameters. The objectives: to know the structures of dams, to know the classification of dams, to know about the parts of dam, to know about the general planning of dams, to know the criteria for structural design of solid gravity dams, and lastly, to know the design parameters of dams and factors of safety. Analysis and design of concrete dams. Classification of concrete dams as per structural behavior. So first is the gravity dams, followed with the buttress dams, and lastly is the arc dams. So this is an example of a structured dam which consists of parapet walls, max water level, freeboard, gallery, hill, toe, sluiceway, spillway, crest, and of course, upstream and downstream of dams. So this also is an example of a dam with its legend. So parts of the dam. Hill. Hill is a contact with the ground on the upstream side. Next is toe, contact on the downstream side. Next is abutment, sides of the valley on which the structure of dam rests. Galleries, small rooms-like structure left within the dam for checking operations. Diversion tunnel. Tunnels are constructed for diverting water before the construction of dam. This helps in keeping the riverbed dry. Spillways. It is the arrangement near the top to release the excess water of the reservoir to the downstream side. Sluiceway. An opening the dam near the ground level, which is used to clear the silt accumulation in the reservoir side. Definition of concrete dams. Gravity dams. A gravity dam is defined as a solid structure made of concrete or masonry, constructed across a river to create a reservoir on its upstream. When this type of structure is most durable and requires very little maintenance. Nowadays, concrete gravity dams prefer as compared to other dams. They can be constructed with ease on any dam site, where a natural foundation strong enough to bear the enormous weight of the dam is available. So, Bakra Dam is one of the many dams that is a gravity dam. So next is the buttress dam. It is a gravity dam reinforced by structural supports. This type of structure can be considered even if the foundation rocks are little weaker. Arc dams. These type of dams are concrete or masonry dams which are curved or convex upstream in plan. Arc dams are built across narrow, deep river gorges. But now, in recent years, they have been considered even for little wider valleys. Classification of dam according to hydraulic design. So first is the overflow dam and next is the non-overflow dam. So what is an overflow dam? An overflow dam is the one which is designed to carry surplus over its crest. Its crest level is kept lower than the top of the other portion of the dam. So the picture shown in the screen is a typical overflow section sample of a dam. So this picture is also an example of a NOF or non-overflow dam. So next is the Non-overflow dam. A non-overflow dam is the one in which the top of the dam is kept at higher elevation than the maximum expected high flood level. Water is not to overtop the dam. So the picture on the screen, this is an example of a standard cross-section of a non-overflow dam. So we can see that the design flood water level is below the crest of the dam. So basically the water can overflow above the crest. So this picture is also an example of non-overflow dam. So this is an typical NOF section or typical non-overflow section of a dam. So for the general planning of dams, general dimensions and definitions. Structural height, the difference in elevation between the top of the dam and the deepest foundation or fresh rock level. So next is the hydraulic height, the difference in elevation between the maximum controllable water surface and the lowest point of the original stream bed at the axis of the dam. Length, it is a distance measured along the axis of the dam at the level of the top of the main body of the dam from abutment contact to abutment contact, including the length of spillway if it lies wholly within the dam. Next is the profile. It is a developed elevation of the intersection of a dam with the original ground surface, rock surface, or excavation surface along the axis of the dam. The upstream face, the downstream face, or designated location. Axis is a vertical reference plane usually defined by the upstream edge of the top of the dam. So next is the section. A section is a representation of a dam as it would appear if cut by a vertical plane taken normal to the axis and is usually oriented with the reservoir to the left. So this picture is an example of a section of a dam. Next part of the general dimensions is local conditions. So local conditions, data on the local conditions will eventually relate to the design, specifications, and construction stages of a dam. Local conditions are needed to estimate construction costs and benefits when considering alternative designs and methods of construction. Some of these local conditions will also be used to determine the extent of the project design, including such items as access roads, bridges, and construction camps. Maps and photographs. A general map locating the area within the state together with district and township lines. Maps showing existing towns, highways, roads, railways, and shipping points. Site topography covering the area of dam, spillway, outlet works, diversion works, construction access, and other facilities. A vicinity map showing the following details: the structure site and alternate site, stream gauging stations, existing man-made works affected by the proposed development, and etc. Reservoir capacity and operations. So this includes area, which is the capacity curves or tables, the topographic map of a reservoir area, the geological information pertinent to reservoir tightness, reservoir storage allocations and corresponding elevations, and required outlet capacities of respective reservoir, water surfaces, and seal elevation, etc. Annual reservoir operations table or chart. Method of reservoir operations for flood control. Maximum permissible releases consistent with safe channel capacity. Anticipated wave action, wind velocity, fetch, and etc. Anticipated occurrence and amount of ice floating debris, etc. Physical, economic, or legal limitations to maximum reservoir water surface. Climate effects. Climate conditions at a site affect the design and construction of the dam as the measures to be employed during construction to prevent cracking of concrete are related to ambient temperatures at site. Construction materials. Construction of a gravity dam requires availability of suitable aggregates in sufficient quantity. Aggregates are usually processed from natural deposits of sand, gravel, and cobbles, or may be crushed from suitable rock. Site selection. The site must be adequate to support the dam and pertinent structures. The area upstream of site must be suitable for a reservoir. Design parameters. Under design parameters is the design flood. As per IS 11223, guidelines for fixation of spillway capacity, dams are classified according to size by using hydraulic head and the gross storage behind them. The overall size classification is greater of that indicated by either of the above two parameters. Classification of dams. So for the small dams, the gross storage is in between 0.5 to 10 cubic meter for the head, so 7.5 to 12 meter. For the intermediate, so for the gross storage, 10 to 60. For the head, 12 to 30. For the large dams, so the gross storage is above 60 and the head is above 30 meters. So for selection of dams, the inflow design flood for safety of the dam is given by, for the small dams, the inflow design flood for safety of dam is 100-year flood. And for the intermediate dam is SPF, which means the standard project flood. And for the large dam, the inflow design flood for safety is the PMF, or the probable maximum flood. So this picture is an illustration of the whole dam and its reservoir. So it consists of the flow, sluiceway, dam body, water index structures, and the spillway. And this is an example of a dam. So for the criteria for structural design of solid gravity dam, forces acting on the dam body. So first it is dead loads, followed by the reservoir and tail of water loads. Next is the uplift pressure, followed by earthquake forces and silt pressure. Lastly is the wave pressure. So this is the vertical cross section showing all the forces acting on the gravity dam that was shown in this slide. So requirement for stability as per IS 6512. Dam shall be against sliding at any section. Safe unit stresses in concrete or masonry shall not be exceeded. Dam shall be safe against overturning. So we all know that this specification or requirements was already discussed in our fluid of mechanics. So we are already familiar with these topics. Check for sliding. The dam should be safe against sliding across any plane or combination of planes. As per IS 6512 in 1984, the factor of safety against sliding is calculated as per the following equation shall not be less than 1.0. So the formula of the factor of safety against sliding is F is equal to, or the factor of safety against sliding is equal to the total mass of the dam minus the total uplift force multiplied by the coefficient of internal friction of the material and all over the partial factor of safety in respect of friction added by cohesion of material at the plane considered, multiply the area under consideration for cohesion over partial factor of safety in respect of cohesion all over the total horizontal force, which is the P. So guys, this is an example of a detailed spillway section. Specifically, this is the spillway of the Polavaram Dam. So guys, these are my references. That concludes my report. Thank you for listening and stay healthy.